Hi friends, I'm very excited to meet you all in another video. Today let's dive into the world of Hazelcast. In this video we will see the introduction of Hazelcast and how to install it in Windows Server using command line interface and some basic operations. Without waiting further, let's dive into the topic. Let's quickly look into the agenda. In the first step we will see the overview of Hazelcast, and in the second step we will just quickly see what are the use cases and feature when to use Hazelcast, right? Third and fourth step is a demo step. In the third step we will see the installation of Hazelcast in Windows Server using CLI, and in the fourth step we will see the basic operations of how to add the data and retrieve them from Hazelcast. Let's start with a brief overview of Hazelcast. Hazelcast is an open source in-memory data store. It is easy to scale horizontally and provide fastest and most scalable approach for application performance. It's very lightweight and easy to use. I know all these things are jargon and definitions, so let us try to first understand Hazelcast in a very simple term by using these two architectures in the slide. Right? On the left hand side of the slide you see a traditional architecture where you have multiple instances of an application running in the top layer. Right? So right now for the example we have taken 3 instances of application which is running and connecting to the primary DB. Primary DB has an backup DB which act as passive DB. So basically this is for fault tolerant. So it's a different concept. So we will have a separate video to explain those terms. But it is for fault tolerant. Say for example, if primary DB goes down, then your application should not crash, right? So your backup DB should take over and data should not get lost. So all these things comes into fault tolerant. But primary DB is the one DB which all the applications connect to, and then that DB responds to the queries from the application. Say for example your application's traffic is getting increased, right? So the one way to scale your application is like you bring in more instances of application. So here in this layer you try to bring 4th, 5th, 6th based on your load what you want to support. Right? But still it will be connecting to the same primary DB. So then how primary DB can take that load? Basically you need to increase the resource of the primary DB server, right? Like CPU and RAM. Right? That's how you can support the multiple request, the load which is coming to the primary DB. So this is called vertical scaling. Basically there is a server, you make that server more powerful. So you can say that way in a very simple term, right? But there is an limit to that. So you cannot keep indefinitely increasing the capacity of the server. So it's a limit to it. So that is where when your load of your application increases in multifold, this architecture will be very difficult to scale. So alternatively, what you see in the right hand side of the slide is a modern architecture where multiple microservices follow this architecture, right? I won't say it is very specific to microservices, but bringing this additional layer of Hazelcast will improve the application performance. So in that way we can take it. So it could be an existing architecture or it could be a microservices architecture. Okay, it doesn't matter. Right? As you can see in this architecture diagram, so it's the same number of applications. It is connecting to primary DB also. It might have an backup DB too. But how you can increase the performance of your application with the same architecture? It is by just introducing this Hazelcast layer in between. Right? So basically whatever the data you want to store, you store it in the DB, but the data whatever you wanted to cache it, which can be cached, that can be stored in the Hazelcast layer. So since it's an in-memory data store, it will be very fast and it is also scalable. I can see that right now you are showing 2 nodes in a Hazelcast cluster. We will be able to easily scale to multiple nodes. So we can see in that in the next slide. But so all the applications will be connecting to Hazelcast and then writing it to DB, and it will act as a cache layer. So in that way, when you have more number of applications getting added to support your applications traffic, you can also scale Hazelcast nodes accordingly. This will support all the load from the application. Right? I hope you got a fairly good understanding what Hazelcast can bring into the table in the architecture. Now we will move on to the next slide to understand the overview. So we will see some key points in this slide. Whatever we have discussed, we will try to elaborate it here. So we have already seen Hazelcast as an open source. It's a distributed computation platform. You can use it as a distributed computation platform. You have a multiple nodes in a cluster. You can submit a computation and then you can get the output of it. So, and it is a storage platform. So we have seen that it is very scalable, right? So how it is scalable? We are saying that it is scalable. You can add the node and it will be able to handle the load, right? So we have seen this, but what it is designed for scalability. See what it all means, right? You can just add a node, additional node to the Hazelcast cluster. So without doing anything, seemingly it will be able to auto discover. It could be able to participate. It will be getting added to the cluster automatically, and the data will get partitioned, and it will be able to replicate in the new nodes automatically. Right, so that is what it is scalable, right? So today you see suddenly when you are getting a more load and you feel that okay, so your Hazelcast cluster also need to scale, you just keep bringing up a new node and then the rest is taken care by Hazelcast. So that's why we say it is it's very scalable, right? It's designed for performance, since all the data will be stored in RAM. It is really fast and it is also fault tolerant, right? Right, we have seen this top point when we are talking about primary DB and backup DB, right? In Hazelcast also, see, you have multiple nodes in a cluster. Right? If one of the node goes down, you should not have any data loss. Just by having one node lost, it should not be that you lose the data what is stored in that particular node, right? So it is the way the Hazelcast is designed to avoid that kind of data loss. Right? That is why it is called fault tolerant. We have seen already, right? The auto discovery of nodes and intelligent synchronization, that is what it helps to be scalable. And the main important point is it is all implemented in Java. Basically all you need is an dependency you wanted to package along with your application, and then your Hazelcast layer will be up. It's that simple. In the next section, let us understand the underlying architecture of Hazelcast, right? Because understanding the basic architecture of Hazelcast will help us to unleash its full capability in our ecosystem, right? So the very important point in Hazelcast that it follows a peer-to-peer model. It does not follow master-slave concept unlike other NoSQL databases. So why it is important? Why we need to understand this model? Since it does not have a master slave concept, there is no single point of failure. Say if it would have followed a master slave architecture, right? When master goes down, then your whole cluster will be down, or it might take some time to bring up a new master, and then underlying architecture would not be that that fault tolerant, right? So it needs some certain steps. Okay? But here each and every node is identical, right? All the nodes can support read and write operation. That is how it is scalable. There is no single point of failure there. Even if one node goes, the other node will be able to take up that particular work, right? So, and also all nodes stores equal amount of data and do equal amount of processing, the computation, right? This makes it very fault tolerant, right? I am keep on saying that the Hazelcast as an architecture, it is very scalable, right? How I am saying it is scalable? So if you bring in another node to this cluster, it will communicate with the other nodes using a TCP communication, as you see here. So it will get automatically discovered by the cluster, and then the data would get replicated or synchronized between the nodes, and then it can also linearly increases the capacity of the cluster in both in memory and computation. So if you keep adding the nodes, then it linearly increases the capacity of the cluster. That's why I am saying it's very scalable. When we talked about the point fault tolerant, I said that if one node goes down, the other node can take up the request, right? For that we need to understand how it can, without any data loss, the other nodes can take up the request, right? To answer that, you need to see the a diagram in the right hand side, where like you have like 3 nodes. So the data first get distributed, right, across the node. So it gets partitioned, right? How it gets distributed? So it has been partitioned, and then the partitions are distributed across the node. Your data is like, say, it can be in the partition P1, P2, P3, P4. As you see here in the diagram, node 1 is the primary owner of the replica P1, P4, P7, P10, which are denoted by green color, and they are called primary replica. Node 1 takes care of those requests for the data in that partitions, right? So but it doesn't stop there. The node 1 also has the other partition, but they are called as backup replica. So which means P2, P3, P5, P6 are backup replica in node 1, but they are the other node acts as a primary replica for that. Say for P1, node 1 is the primary owner, right, and it is a primary replica here in this node, but the same P1 it is in as a backup replica in node 2. Okay? So that's how at some point of time when node 1 goes down, right, it's also a system. So each node in the cluster is also a system, right? It doesn't since it is a node for Hazelcast, it doesn't mean that that particular system will crash, or sorry, the particular system will not crash. It can crash. So at some point when that system get crashed, automatically the node 2 will take up the request for P1, P4, P9, P12, and then that would also become the primary replica, and then it will be able to handle the request to those data. And that's how I say there won't be any data loss. The Hazelcast cluster would be able to process all the requests and then respond to the queries. In this section we will see features and use cases where we can use Hazelcast. So the first feature is distributed data structure. Under that it supports map, queues and concurrency utilities. Maps and queues, it uses the similar application programming interface, that is API of maps and queues in Java. So the developers would be easily use the same understanding and use this data structure here in Hazelcast. The next one is distributed computing. So under that it supports executor, entry processor and pipelines. Here executor also follows the similar API as in Java executor, so it is easy for the developers to understand. The next one is distributed queries. So we all know SQL is a popular language which we can use this language to get the data from database. Similarly here the Hazelcast will be able to understand these SQL queries, and then it can query the data whatever it's stored, and then it can provide the result based on the SQL query. So this feature is those who have used Apache Kafka, they would know, because they in Apache Kafka also it supports similar interface where you can write in SQL and then you will be able to get the data, right? Now let us go into use cases. These are all the real world use cases which you can also use Hazelcast to solve these use cases in your project. These are all some use cases which I have personally used in the projects which I have worked on, right? So in the first slide we have talked about it improves application performance, right? What it means by improving an application performance is nothing but you provide the response to the client faster. These are all very much important in e-commerce websites where you open any web page or you provide any operation, so it has to be in milliseconds, right? The user cannot wait, so that is very critical, right? That is the first use case which I can tell the Hazelcast can solve, because all the data it stores in RAM, so it will be able to provide the data in milliseconds compared to milliseconds or sub milliseconds, right? So then compared to any database, because in database if you provide a query, it has to go to the disk sometimes, and then it needs to take up the data, so definitely it cannot respond in some millisecond. Okay? This is one of the critical use case which we have solved in many applications. Right. The next again important one is storing session data in web application. Right. In a traditional web applications, monolith applications, so we would have, say, an application server or servers which will be running your application, and there will be a web server in front of that application server which will route the request. Right. So the session data is stored in JVM of the application server. Right. So wherever the web server routes the login request, then after login also all the request of that particular client it has to route to the same application server, because the session data is stored in that particular JVM. If it goes to the next server, that will not understand and it will think that that particular user have not logged in, right? Because it doesn't have that logged in details in that JVM. That's how we used to load balance in the traditional monolith application. But in given modern architecture where we follow mostly microservices architecture, where we bring up the application instances just like that to increase the capacity of your application, so this sticky session concept won't hold that doesn't hold good here, right? So you need another mechanism. That is where you can bring in Hazelcast, which stores the session data in memory, and all the application instances can connect to the session data, and then they will be able to share that particular data. So the next point is also very similar, sharing data sets. If you want to have some data which needs to be shared across your multiple application instances, then definitely you can store it in Hazelcast, and then you can easily share it, right? The next use case is also very important one, which I have used extensively in other projects. That is called as distributed locking. Let us bring into the same traditional architecture where you have multiple application servers, right? Say you are building an ticket booking system. You would have used multiple apps, right, of ticket booking systems. So you try to lock a seat, and then you try to go for a payment page and then pay it. So it's not that only you will be locking that seat, or you will be wanting that seat, and then only you are exclusively going for the payment page, right? There might be other users, hundreds of users, who will be trying to book the same seat, right? What if everybody goes to the same payment page and pays it, right? At least only one would be getting the seat, right? So you need to properly manage it. You have to go to the payment page only if somebody able to lock that seat before going to the payment page, so that if the payment is successful, they will be able to get the seat, correct? So that cannot happen in a traditional or I would say in an architecture where Hazelcast kind of layer is not present, which provides distributed locking, because each application instances will be having their own JVM. If it is only one JVM, it is very simple, right? You can use object lock, and then you can streamline. Okay, once your object lock is there, then other requests cannot get the same seat, correct? So if it is a simple JVM, a single JVM application, it is very simple to handle this kind of you can easily have a lock, object lock act as a gatekeeper, correct? But that does not happen in a distributed architecture where you have multiple application instance running. That is where you could use Hazelcast to provide a distributed locking feature, such that only one request can lock the particular seat, and then it can proceed for the payment page, right? That kind of use cases you can easily solve using Hazelcast, and I have used in multiple projects. It's a very easy and very effective. Now coming to the last use case, which is leveraging executor service to perform calculations across the cluster, right? Like in a Java, we have an executor service. You can submit the job, it uses the multi-core capability in a single JVM in that single system, and then it runs the job parallelly and then provides the output, right? So here we have a cluster, we have a nodes. So in each node, the Hazelcast submits the particular job, and then it will be able to provide the result, right? When your cluster is huge, then you have a lot of computation capability, right? It doesn't limit to single node and single CPU, correct? So these are all some of the most important use cases which I have personally solved it using Hazelcast. In this section, let us see the installation steps to bring up an Hazelcast node and Hazelcast client from the command line interface. So I am going to demonstrate this from the command line interface because it is easy to set up or bring up a Hazelcast node in the command line interface. But please keep following up my channel. I will come up with another video which will demonstrate how to start an Hazelcast node from an application, Java application, and how you can use Java client to connect to an Hazelcast cluster and then query the data, right? So now let us get into the steps. The steps are very simple. You go to the Hazelcast downloads page, download the zip archive of a required version. Now you set the you install a JDK. I am going to use JDK 17 here. So you have to set up a Java underscore home environment variable pointing to the JDK. Next step is to unzip the zip archive what we have downloaded in the desired location. Open the bin folder, and from there you open a command prompt and then just type the command hz-start.bat. It is as easy as simple and easy to bring up an Hazelcast node from the CLI. Okay, now let us go into the steps to see how to bring up an Hazelcast client. So you just open another command prompt, and in the bin folder type the command hz-cli.bat console. This command just connects to the node which has come up in the previous section, and then it will be in the command prompt ready to accept the Hazelcast command. Right now it's time to see all these commands in action. So download the required version from Hazelcast downloads page. So I have downloaded this zip archive, which is of version 5.3.6, and then I have also unzipped the zip archive in this location. So I have opened the command prompt. So there are 4 tabs just to explain the different scenarios. I am planning to start 2 nodes. So that is why I have named it as node 1, node 2, and then there are 2 clients, client 1 and client 2. All are in the bin directory. I also set up my Java home. So let us start the Hazelcast first node, right? I just provide hz start .bat command. So now the node is starting up. Node is up. It is listening in 5701 port. So the first node is up, right? Let us now try to connect to the first node using the command -cli/console. Now it brings up the CLI console, and now it entered into the prompt, which is ready to execute the Hazelcast instructions. It is connected to 5701, and +0 here means there are no other nodes in the cluster. It's only one node, and it is listening in 57, or it is connected to 5701, right? So you can just type help command to see all the commands here, which is supported by CLI. So we are going to take a map data structure, and we will run few basic commands to understand, so that similarly you can run the commands to the other data structure, right? Okay, so let's say m.put. Okay, so key 1, and I'm saying value as US. So this puts an entry into the map with the key as key 1 and then a value as US. So it responds with null. It has put the key 1 into the map. So let me try to get it using m.get command. When I say key 1, it returns the value US, which is the value stored for the given key, right? So you can also see what are the entries. Oh, sorry, my bad. Yeah, so you have total 1 entry, and you are also seeing the value of it, right? So let us do one thing. Okay, let us bring up node 2, okay, and then see how it connects to the cluster. It is bringing up the node 2 in the cluster. See, it's automatically communicating to the node 5701. It is able to establish the communication. Right now you have 2 members in the cluster, right? You can also see the relevant logs here that the connection is attempted to made by another new node, and then it is able to establish that, and it has already rejoined the cluster, right? So it will also have some messages related to partition. Okay, so whether there is any repartitioning of the data required, all those things you can see here, right? Now the cluster is up with 2 nodes. Now you can also bring up the second client, which I say is hz-cli.bat/console, right? So here the second client is also up, but here you can see it is also connected to 5701, but you can see +1 here, which says there is another node in the cluster, right? Now I have inserted the map from client 1, so you can assume this is one application instance where I have entered or I have loaded the map with the data. And now it is another instance. You can query the same key in the map, and you can see whether it is able to give the data, right? So you see here you can able to get the data for the key 1, which is US, which we have already added to the map, right? So this is how multiple application instances can connect to the Hazelcast cluster and then get the data. It can share the data, right? Now we have demonstrated basic operations in the map. I wanted to also demonstrate one of the key use case which we solve, right? Distributed lock. So you can see the commands, how you can execute the lock. Let us go and execute the lock command here, right? I use try lock command. So and then you give the name of the lock, Europe, right? So it returns back with me as a boolean true, which means I am able to successfully lock for the name. I obtained the lock for the name Europe, right? Now let us try to obtain the lock for the same name from the second client, and you can see what is the response. See, here I got false because it has been already logged by another client, so I can know that this particular name is already logged. So then based on that I can proceed with my use case. I can either wait or I can show the error message to the user. That totally depends on the application use case, right? Now how to release a lock? You just say unlock and then you say Europe. Now the first client have released successfully the lock on Europe. Now you will be able to run the command again here in the client too. Now you can successfully lock. I'm just unlocking it, right? So these are all some basic operations. One more thing I wanted to demo. See, we talked about fault tolerant, right? See, I have right now 2 nodes, correct? I have started 5701 and then 5702. Let me bring up 5701, right? And then let us see how the client is able to still query the maps, whatever we have added, without any issues. Right now I have terminated the node 1, and you can clearly see that it identified that node 1 has gone down. Right now there is a cluster only with one node, and then you can see here since we do not have much data, there is nothing, there are no partitions, so it clearly says that the partition balance is okay. There is nothing need to there is no need to repartition it, right? Now yes, it threw a error here because it was connecting to 5701. Now you no need to do anything, just press enter. You can know that it automatically connected to the second node in the cluster. So how you can verify it? You can run the who command, and then you can see that there are only this member, and then it is able to connect to this member in the cluster. Let us try to get the entries in the map. See, you can still able to see that entry key 1 and US, though the first node has crashed, still there are no loss in data. So this is how the architecture of Hazelcast supports fault tolerant, which is very important feature. That's all for this video. I hope you like this video. If you really like the content, please like the video, share it with your friends, and subscribe my channel. Thanks a lot, and see you soon in another video.